This video is about to review for statistics. For A, the mass M of apples in grams is normally distributed with the mean mu. The following table shows probabilities for value of M. According to the property of probability distribution, this number adding equals 1, which means pi, the sum of pi equals 1. Therefore, we have k plus 0.98 plus 0.01 equals 1. Therefore, the k equals 0.01. For B, show that mean equals 106. There are two ways to do that. According to the property of normal distribution, we have probability of M less than 93 equals 0.01. Probability M greater than 119, that equals 0.01. Therefore, the mean equals 93 plus 119 over 2. That equals 106. The reason why we do that is the normal distribution graph is symmetric across this mu. And these two equal. Therefore, the mean point between 93 and 119 will be the mean. The second method is using z-score. So we will figure out the z-value for M less than 93 and M greater than 119. For the probability M less than 93, since this is less than, therefore, we can put 0.01 directly to the graphing calculator. Then the mu equals 0, sigma equals 1, you will get z-score equals negative 2.32634. And for probability M greater than 119, we want to figure out the z-score. You have to change into probability M less than equals to 119. Because for this area, which means the probability, you have to make sure the variable less than or equal to k. So we get the 1 minus 0.01, you will get 0.99. We put the 0.99, you will get the z-score equals 2.32634. Then we put into z-score formula, z equals x minus mu over sigma. We plug in negative 2.32634 equals x will be 93 minus mu over sigma and 2.32634 equals x will be 119 minus mu over sigma. Then you will take a sigma outside. You will get switch this two, which means 93 minus mu over negative 2.32634. And here, sigma equals 119 minus mu over 2.32634. Then you set up, this is y1 in the graphing calculator, y2. Then get the intersection, mu equals 106, and sigma equals 5.58815. If it's not the value we are looking for, it's just middle value, try to use accurate answer like this. Let's go to 4C. Find the probability m less than 95. So 95 will be the upper. We got to use norm CDF. Lower will be -1E 99. The mean will be 106. Sigma, that is a 5.58815. You will get 0.0245. Since this is the final answer we're looking for, try to use 3 significant figures. But like a sigma, it's not the value we're looking for. Try to use the accurate answer. Let's go to 4D. The apples are packed in bag of 10. There are 50 bags in a crate. Any apples with a mass less than 95 grams are classified as small. Find the expected number of bags in this crate that contain at most one small apple. According to the formula, expected value for binomial distribution, it will be n times p. So 50 times probability. We need to figure out the probability contain at most one small apple in a bag. This is a binomial distribution. Therefore, we're looking for probability x less than or equals to 1, which means probability x equal to 0 plus probability x equals to 1. There are 2 ways to do this. First of all, let's use this formula. This formula is for binomial distribution. Therefore, you will get 10 apples. None of them is a small apple. So we have a probability for small apple is 0.0245. 0.0245 to the 0 power times 1 minus 0.0245 to the 10th power. Then plus 1 apple is small, 10 apple altogether, then 1 is a small. We do 0.0245 to the first power, then 1 minus 0.0245 to the 9th power. You put into a graphing calculator, you will get the 0.976. Or you can use the binomial CDF. Trial is 10. Probability will be 0.0245. X value will be 1. CDF, which means the X less than or equal to 1. Then you enter, you will get the probability equal 0.976. You will get the same answer. Therefore, for expected number equals 50 times this probability, which means 50 times 0.976 equals 48.8. Let's go to 4E. Find the probability that at least 48 bags in this crate contain at most one small apple. We already figured out for 1 bag, this is the probability to get one small apple, at most one small apple from a bag. Therefore, this still will be the binomial distribution. We are looking for probability x greater than or equal to 48. When we use the binomial CDF, this x value must be x less than a. Like this, you can put into this number. Therefore, you have to turn it into 1 minus probability x less than or equals to 47. Make sure you do have this equal sign when you put into this binomial CDF. Therefore, you will put in trial is 50. Probability is 0.976. This will be 47. Then you put enter, you will get 1 minus 0.1183790 and so on. Then the final answer you will get 0.882. Let's go to 5a. The random variable x is randomly distributed with a mean of 100. Therefore, this is 100. The following diagram shows the normal curve for x. Let R be the shaded region under the curve to the right of 107. The area of R equals 0.24. Write down the probability x greater than 107. That equals 0.24. Remember, for the normal distribution, the shaded area will be the probability. Now go to 5b. Find the probability x greater than 100 and less than 107, which means this area. It will be equals to 0.5 because probability x greater than 100, that equals 0.5. Therefore, between 100 and 107, we got to use 0.5 minus 0.24. You will get 0.26. Then find the probability this x greater than 93 and less than 107. 93, you will draw over here, 93. Since this is adding 7, and from here to here, that is we minus 7 from 100. Therefore, the normal distribution is symmetric across this mu, which means it's mean. These two area will be equal, which means if this is 0.26, this will be 0.26. Therefore, from 93 to 107, you will get 0.26 times 2. You will get 0.52. Let's go to NonA. A competition consists of 2 independent events, shooting at 100 targets and running for 1 hour. The number of targets a contestant hits is the S-score. The S-score are normally distributed with a mean 65 and a standard deviation 10. A contestant is chosen at random. Find the probability that their S-score is less than 50. This is a normal distribution. We are looking for probability. We go to normal CDF. Since we're looking for the probability x is less than 50. So lower will be -1, E 99. upper will be 50. The mean, that is 65 given here. Standard deviation is 10. So we put into graphing calculator, you will get 0.0668. Let's go to 9b. The distance in kilometer that a contestant runs in 1 hour is R-score. The R-score are normally distributed with the mean 12 and the standard deviation 2.5. The R-score is independent of the S-score. Contestants are disqualified if their S-score is less than 50 and their R-score is less than X kilometer. Given that 1% of contestants are disqualified, find the value of X. Since the R-score is independent of S-score, which means this is the formula you got to use. Therefore, probability of S less than 50 and R less than X kilometer equals probability of S less than 50 times probability R less than X. This equals 0.01. Therefore, the probability R less than X equals 0.01 over probability S less than 50. So you get 0.01 over 0.0668. We got this number from 9a. Then we use the inverse norm. Since here's a less than, which means this number you can put into this area, 0.01 over 0.0668. The mean, that is 12. Standard deviation is 2.5. When you put into a graphing calculator, you will get the X equals 9.41 kilometers. Let's go to 10a. A machine manufactures a large number of nails. The length L millimeters of a nail is normally distributed where L is distributed as normal distribution 50 and sigma square. Find the probability L greater than 50 minus sigma less than 50 plus 2 sigma. As we know, for the normal distribution, this is you add 1 sigma, add 2 sigma, then you add 3 sigma. Here is you subtract 1 sigma. So 50 minus sigma, that will be here, 50 minus sigma. 50 plus 2 sigma will be here, 50 plus 2 sigma. We are looking for the area for this and this. Therefore, the probability equals 2 times 34.13%, add 13.59%. You will get 81.85%. If you cannot remember this diagram, there is another way to do it. Use a Z curve. We have -3, -2, -1, 0, 1, 2, 3. Basically, we are looking for from -1 to 2, this probability. It will be the same as this. Therefore, we go to lower will be -1, upper is 2. We put the 0 and 1 for mean and standard deviation. The probability you will get, that is 0.81859 and so on. So we use the Z-curve to remember the diagram of normal distribution. Let's go to 10b. The probability that the length of a nail is less than 53.92 millimeter is 0.975. Show that sigma equals 2. We are looking for this, the probability this L less than 53.92, that equals 0.975. But we're looking for this sigma. You are given the mean is 50. When you're looking for standard deviation, you have to get the z-score first. Then using the z equals x minus mu over sigma to figure out this sigma. Go to inverse norm. The area we put in, that's 0.975, because here is less than. So this number we directly put in. Then we put the mu and sigma 0,1 separately. You will get the z-score equals 1.95996 and so on. Since this z-score is a middle value, don't use 3 significant figures and make it accurate. Then we plug in here 1.95996 equals x will be 53.92 minus 50 over sigma. Then the sigma equals 53.92 minus 50 over 1.95996 equals 2.00. Now let's go to 10c. All nails with length at least t millimeters are classified as large nails. A nail is chosen at random. The probability that it's a large nail is 0.75. Find the value of t. According to the information, we know this L greater than equals to t. That is 0.75. We need to go to inverse norm. For this area, you need to put in probability x less than equals to k. Therefore, for this one, you have to turn into probability L less than t equals 1 minus 0.75. That is 0.25. So we have 0.25. We got this mean is 50. The standard deviation is 2. Then we put into graphing calculator. You will get the t equals 48.7 millimeters. Now let's go to 10d. All nails with length at least t millimeters are classified as large nails. A nail is chosen at random from the large nails. Find the probability that the length of this nail is less than 50.1 millimeters. This is a conditional probability because this nail is chosen from the large nail. Therefore, we're looking for the probability We already know this t is a 48.7. That is a t greater than equals to 48.7. Then we're looking for this t is a less than 50.1. Therefore, using this formula, A given B, that equals probability A intersect B over probability of B. You will get probability this t is greater than equals to 48.7 less than 50.1 over probability this t greater than equals to 48.7, then equals. So we go to normal CDF. Lower is 48.7. Upper will be 50.1. Then the mean, that is 50. And a standard deviation, that's 2. So we put into a graphing calculator, you will get 0.26209. Then divide by 0.75. So you get 0.349. Let's go to the last question. 10 nails are chosen at random from the large nails. Find the probability that at least 2 nails have a length that is less than 50.1 millimeters. We know this is a normal distribution. We are looking for the probability x greater than equals to 2, which means 1 minus probability x less than equals to 1. You can use a formula like 10, I choose 0, 0.349 to the 0 power, and 1 minus 0.349 to the 10th power plus. This 10, then you choose 1, 0.349 to the first power, and 1 minus 0.349, you do 9th power. So you put it into a graphing calculator, then you use 1 minus this number. Or you use this binomial CDF. 12 is 10. Probability is 0.349. X value is 1. You have to put in probability x less than this number. You will get the probability x less than or equals to 1 equals 0.0870. Then we plug in here 0.0870. Your answer will be 0.913 from here.